Good morning, everybody, and welcome back to Next Door NetAdmin. I had a little bit of an interesting time earlier today, and I'm going to show you what I was doing. I was doing default route injection and removal with IP SLA tracking in Cisco. So this is going to be a little more of a wonkish topic, but hopefully it's interesting to everybody anyway, and I can explain it in a way that makes sense, whether you're experienced, new to the topic, or just watching for curiosity. Let's dive in, shall we? So, here on my dev machine, I've got a configuration snippet. It's a snippet, it's not a full configuration, but it shows what I had to start working with earlier today. As you can see, we've got a bunch of things. This is roughly the order in which they appear in the full configuration file, but let's swap it around a little bit so that, am I going to swap it around? No, I'm not going to swap it around. I'm going to leave it like this just so that it's similar to what you would see if you actually dumped a router or a switch's configuration. You would see the stanzas in roughly this order. That's my story, and I'm sticking to it. But what does this do? The point of this is primarily to do an ICMP echo or a ping to a pair of IP addresses. In this case, one is Google DNS primary and the other is Google DNS secondary. And based on these particular ping responses, I have two routes that will be injected into the router or not. 10.32.255.1 is one of my exterior gateways at this particular site, and 255.3 is the other online gateway at this time. They both have connections to the internet. They're roughly there for failover, so that if we take one down for maintenance, the other one can still be forwarding traffic to the internet and vice versa. Fairly simple. In concept, at least. Not every site is big enough to have two separate firewalls and connections to the internet. So that's a thing. But basically, when you configure this SLA, service level agreement is generally what that stands for. It has a number, 1. You configure it with the address that you want to ping. There are other things that you can configure in an SLA, but for this, I'm just demonstrating ICMP echo. You have some parameters for threshold, how long it takes to time out, how often it should ping. And then once you've configured that, you start it with IP SLA schedule 1, life forever, start time now. That starts the SLA tracking. Okay. Or at least it starts at pinging. The tracking actually happens up here. Track 1, we're creating a tracking object, number 1, which is confirming IP SLA 1's reachability. And for delay, because you don't want it to toggle immediately, when it's down, you want to detect that relatively quickly. So you have a lower number, in this case 10. After 10 seconds, it detects that it's down. When it comes back, you want to allow a little more time to confirm that it's stable so that you're not, changing the state of things too quickly. So when it comes back up, we want to wait 30 seconds before we mark it as available again. Okay. And then we do the same thing with object number 2. We're pinging a different IP address. We're scheduling it to start, and it's got much the same configuration for reachability, with the same parameters. Now, how do you make sure that these two pings are actually going out two different gateways? Because it's not going to do any good if they both go out one gateway or the other. That's what this section is for. This specifically says anything to 8.8.8.8 goes out gateway 1. period, all the time. Anything going to 8.8.4.4 goes out gateway 3, the second gateway, all the time. So that when this pings, it's always checking that this is associated with gateway 1, and this one is always associated with gateway 3. I'm going to call it gateway 3 just because that's its IP address. Fine. Based on these two tracking objects, if this is up, then the internet connection is working through gateway 1, in which case you're going to make this default route to 0.0.0.0/0 through gateway 1, you're going to associate it with tracking object 1. Cool. That works for me. This other one, through gateway 3, is also a default route candidate. You can use it for all traffic. I'm going to put it in with administrative distance 2. By default, a static route is administrative distance 1. So this has the effect of inserting it at a slightly lower priority than the default in case something brings it back, or in case I've configured something else at default priority 1 and forgot to connect it to a tracking object. So at priority level 2, it's going to be associated with tracking object 2. That's as simple as it gets. But that's where I started. Now, what I wanted to accomplish today was adding a third WAN connection to a different ISP. This third internet connection is going to be connected to gateway 1. But how do I know whether I'm testing the connection on gateway 1, internet 1, or gateway 1, internet 2? And if I am doing that, then I want my default route through gateway 1 to depend on either of those objects. I will confess I have to do a little bit of hand waving here because in order to actually get the two different pings to go out two different connections, I also had to change some of the configuration on the firewall itself, and I'm not showing you that today. But let's take it as a given that I've set up the firewall so that everything that's bound for 8.8.8.8 goes out internet connection 1, and everything going to this other IP address is going to go out internet connection number 2. So we'll take that as a given. And with that, let's take a look at what we're adding. I'm actually going to take everything that we're adding, and I'm going to copy it into our original configuration. And then I will put these configuration snippets into where they should actually be. In this case, we're going to say that internet connection 3 is going to be tested by pinging route 1.1.1.1. And I'm making sure that that's also going through gateway number 1. Perfect. Gateway number 1, firewall number 1, will handle the separation of which internet connection this goes out. All I need is to tell my interior devices exactly what I want them to ping for their tracking. All right. So then we've got IP SLA 3 echoing to 1.1.1.1, same settings as the others. Tracking object number 3, also the same as the others. We'll put that right there. And now comes the fun part. We're going to create another tracking object. Track 11, list Boolean OR. Okay, what does this do? Well, in this case, we're not tracking an IP SLA directly. We're tracking other tracking objects. And when we're going to do a list, we can use Boolean logic with this. Boolean logic being and, or. You can also do not, but not at this level of the stanza, which gets a little dicey sometimes. But for this list, you can do Boolean and or Boolean or. And I'll show you in a minute how you can use this to manipulate things a little bit. In this case, we're going to track object 1 and object 3. We know that object 1 and object 3 both go out gateway number 1. And I'm not keeping these numbered consistently because this is roughly the priority order in which I want to use them. Priority 1, I want to be going out internet 1 on gateway 1. Priority 2, I do want to be gateway 3 because it's also got a pretty big internet connection, pretty big pipe. But third priority, I want it to be this tertiary internet connection, internet number 2 on gateway 1. So for this, I want to track both of these objects. If either one of them is up, then I can use this default route. It won't be optimal all the time, but we can actually use it. So I'm going to then say no IP route on track 1, which is this one here. And to replace it, I'm going to add the IP route to gateway 1, tracking object 11, which depends on objects 1 and 3, and it can be either one of those that's up that keeps this default route valid. And as long as that's valid, we won't fall through to this other one. Now, admittedly, that's not entirely the way I want it to work. There's a little bit of fine-tuning that needs to be done, but this is sufficient to show you the basic grasp of what we're doing. Now, for funsies, what would we do if we wanted... Do I want in this window? No. What would we do if we wanted something to become valid if and only if these two were both down? Let's say instead of using track 2 for this, we're going to do something completely different. I'm going to put a big empty space in here. Okay. Let's say we're not tracking object 2 for this. Let's say I want this to be injected if and only if these are both down. Can I do that? Because these objects only become valid if they're up, not if they're down. Here's where we get some interesting shenanigans that you can do with Cisco tracking. What if I do track 22, list Boolean? Now I can only use and or at the top level. So it's and or. I have to pick one of those. Well, these I know are my objects for gateway 1. You can add a not on individual object entries. And I'll just solve this by saying we want Boolean and for this. Because if object 1 is down, the not means that it's now considered up. And if object 3 is also down, then the not also makes that up. Boolean and means if they're both up, or in this case down because of the not that we set there, then the track becomes valid. And so instead of doing a direct track on 2, you could also do an indirect track on is object 1 down and object 3 is down. Then this tracking object becomes up, and we can install a second default route pointing to gateway 3. So there's more than one way that you could do this. Obviously, this is a little more convoluted to try and figure out as you're reading it. And it requires some mental gymnastics to go, okay, well, is it this, is it that, versus just, I want to just track object 2 pinging another IP address through a different gateway, and I want to call it good. But having this sort of flexibility is the kind of thing that makes your life as a network administrator mildly more, I don't even know if I can say it's easier, in all honesty, because this is not especially easy, but it gives you more flexibility. It gives you some additional tools in your tool belt, as it were, that you can use to work with unexpected situations. As an example, if you're using something like policy-based routing, maybe you want to send traffic to another destination, not if the other gateway is up, but only if your primary gateway is down. Possibly the primary gateway has more bandwidth, possibly it's on a cheaper connection, maybe your backup is on a cellular connection or something, and it's going to charge you an arm and a leg and a kidney in order to use it. Okay, maybe the only reason you want this to be used is if the others are affirmatively down, in which case you can use something like this construction to create a tracking object that is up when everything else is down, and that will allow your policy-based route to fire traffic out to the other connection. Even though it's expensive, maybe it's better than being down. So in this way, you can have some flexibility to deal with things even if it looks really weird and it makes you have to think a lot in order to do it. So that's it. That's just an alternate construction, an alternate way of getting to the same end result. And that's what I was working on this morning. So now you've had a little bit of insight into my life. And yeah, hopefully that was interesting to you. Maybe it was useful. I certainly hope it was. If you have thoughts on anything else you would like to see me cover, feel free to let me know down in the comments. If you have any questions, that's the best place for them as well. Otherwise, until next time, I am your next door net admin, and we will see you next time.